So I have gone on and on about how if you have things multiplied, you can't just do their individual derivatives, right? And we've seen that we had to multiply things out before we do the derivative. If I wanted to try to do an example of that to just prove it to you, if I said like 2x to the fourth times 3x plus 1. Okay, if you did the derivative if you try to do the derivative of each piece, the derivative of that first piece is 8x, derivative of the second piece is 3, and you would get a derivative of 24x, right? If you try to do the thing that I keep telling you not to do, just do the derivative of each one. If you multiplied it out first, we get 30x to the fourth plus 8x to the third when we do the derivative. So clearly those are very different things. So that's why when I keep telling you, you can't just do the derivative of each piece, that's why. It just doesn't work. You get a totally different answer rather than when you multiply everything out first. But there are times where we may have something that we can't multiply out. If I said e to the x times x to the fourth, can you multiply those and just get x to a power? No. So we have no option to simplify it first. So we have to figure out how to do this derivative and get an accurate answer even when things are being multiplied. So that's what we are working on today with our product rule. So the rule for this, we can't just do the derivative of each piece. There's a big long proof for that, why this works. But if you have the derivative of two things being multiplied together, you essentially do one derivative at a time times the other one. Okay, the way I normally write this, I usually say the derivative of the first times the second plus the first times the derivative of the second. So we take the things being multiplied, we do the derivative of one of them, leave the other one the same. Plus, and then you flip it. You do the derivative of the other one, leave the first one the same. And this can be extended to more than two terms. You just essentially do one derivative at a time while leaving all the other pieces the same. And that would give us the correct answer. So, let's go back to my little example that I was doing here and just kind of verify it. So this was our derivative. And we know that this one didn't work, right? If I try to do the product rule, it says one derivative at a time. So we see this is the first thing, this is the second thing. Those are things being multiplied together. So product rule says derivative of the first thing. So the derivative of 2x to the fourth is 8x cubed times the second one plus, now we leave the first one alone and do the derivative of the second one. Derivative of 3x is 3. So if I multiply this out, we get 30x to the fourth plus 8x cubed, which is the same answer I got when I first multiplied and then did my derivative. So do you believe me that this works now? We've seen the example, we knew what the derivative should be, and we used the product rule to get it. So the first few problems that I'm going to do the product rule with, it may not be necessary. Like this problem, I could do it with the product rule and that wasn't a big deal, but wasn't it faster to multiply it out first? Yeah. And that's still going to be true. There are some cases where we can't multiply it out, like when we have an e to the x times x to the fourth. In that case, we have no choice but to use the product rule. But if it is something that you could quickly multiply, you may choose to do that first before doing your derivative, and that's okay. Today, I'm just going to practice the product rule so I'm not multiplying it out just because I want to verify that this rule works. I want to practice it. I've asked you to do this derivative without multiplying it out first. Do you guys understand when I keep saying we have to use the product rule, we have things being multiplied together? What I mean is the first parenthesis has an x, the second parenthesis has an x. So we have two expressions, both of them have variables. So if I'm multiplying that, that's when I have to do the product rule. So when the x shows up in both. So the derivative. Derivative of the first one. So what is the derivative of 1 minus 4x cubed? You get 4x squared. You leave the second one alone. Plus, now we leave the first one alone. And we do the derivative of the second one, which is everybody with me there? What would I need to do at this point? Yeah, multiply it all out. So the product rule really isn't a time saver on this problem, but we're starting with polynomials so that when we get to the ugly stuff, we know the process. Okay. So if I distribute, we get a negative 36x to the fourth plus 60x cubed minus 24x squared. And then this one we have to FOIL, so we get 6x minus 5 minus 24x to the fourth plus 20x cubed. Add like terms, so negative 36 and negative 24 will be a negative 60x to the fourth plus 80x cubed minus 24x squared plus 6x minus 5. Any questions on that? Alright. Is this one that we could multiply out? No. So we would have no choice but to do the product rule. And the reason we have to do the product rule is because we have more than one x, more than one variable here. So my function, f of x, I have an x times an e to the x. So part A is asking for the first derivative. So I have to do product rule. Derivative of the first would be 1 times the second plus the first one, which is x, times, what's the derivative of e to the x? So I'll just get e to the x plus x e to the x. We've kind of seen with polynomials, as we do their derivative, it gets nicer each time. That's not the case with a lot of expressions. So when you start having fractions, radicals, e's, trig functions, the derivative actually gets nastier as you go on. So polynomials are kind of the exception. So part B, I'm basically asking, can you figure out a pattern here? So how we could quickly find each of these derivatives. We found the first one, let's do the second one. Okay, we know we can do the derivative term by term, right? So the derivative of the first term, the derivative of e to the x is e to the x plus, now I need the derivative of x e to the x. How would I do that? What do we have to do the derivative of x e to the x? Product rule. Derivative of the first. Derivative of x is 1 times the second plus the first. Derivative of the second. Derivative of e to the x is e to the x. Alright, so I have e to the x plus e to the x. That's 2 e to the x. And I still have x e to the x. You guys see a pattern yet? So what do you think the third derivative would be? So the nth derivative, basically a shortcut for the 5th, 7th, 10th, whatever number I gave you, is just n times e to the x plus x. So we just had to do a few derivatives until we could see a pattern. And we can go from there. Questions on that one? Let's do another one with product. So if I wanted, could I multiply this one out? Yeah. And after today, you probably would choose to multiply this out first because it would be a little faster, but we're trying to learn the product rule with some nicer problems before we get to ugly ones. Okay, so let's try the product rule. I should probably, though, at least rewrite it. Instead of the square root of x, what would I call that? So, my derivative. We have this parenthesis times that parenthesis. So product rule says derivative of the first one. What is the derivative of 3x plus 1? Times the second one plus the first parenthesis times the derivative of the second parenthesis. So the derivative of x would be 1 plus the derivative of x to the 1/2 . So then for my final answer, I can go ahead and multiply this out a little bit. So we get 3x plus 3x to the 1/2. Factorial 3x plus 3/2 x. 1 plus 1/2 is 1/2. Plus 1. Okay, combine like terms. Doesn't really matter what order you have them in, as long as you have all the terms. So those are both x to the 1/2. So 3, that's like 6 over 2 plus 3 over 2. So that would be 9 over 2. So, product rule, you You do one derivative at a time, leave the rest the same. I'm going to skip examples 4 and 5 for now. We'll do those tomorrow for more practice. I want to go ahead and talk about the quotient rule a little bit. So quotient, that's when things are being divided. And just like with multiplication, we said when we have a fraction, you cannot just do the derivative of the top and derivative of the bottom. So we've been trying to simplify them first. But that's not always an option. The problems that I've given you, we're able to simplify because we are dividing by just a power of x on the bottom. But if I gave you something like this, could you simplify that first? No. We can't just bring up an x to the negative 5 because it has that plus 2 with it. So if it's more than one term on the bottom, we can't just write it as a negative exponent. And so we need a different option. So the quotient rule is it looks a little more confusing than the product rule, but it's actually not too bad. So this is the notation that your book gives. Different ways to think of it. So it's basically the derivative of the top times the bottom minus the top derivative of the bottom over the bottom squared. Okay, so it's kind of like the product rule where you do one derivative at a time. But because these are subtracting, the order really matters. So you do the derivative of the top one times the bottom minus top times derivative of the bottom over the bottom squared. Another little trick for this, you can say low d high minus high d low over low squared. Okay, and that's the same thing. Low, so the bottom one, d high times the derivative of the top, minus high, so the top one, d low, derivative of the bottom, over the bottom squared. So whatever kind of helps you, I usually say that phrase a lot as I'm trying to help people do these, so you'll probably hear that frequently. It'll probably stick in your head before we're done. So I would like to try a few quotient rule problems. So I'm asking for the derivative of this expression. Now, is this one we could do without the quotient rule? Yes, because the bottom's just one term. We could simplify it and do it the other way, and that's probably faster, but we're trying to learn the quotient rule, so we're going to do quotient rule here. So, low, the bottom, d high, derivative of the top, minus high, d low, derivative of the bottom, over low squared. Okay. Let's try to clean this up. Is everybody okay with how I set up that first fraction? So if we distribute, we get 40x to the fifth minus 12x squared. Can I distribute this negative and my 4x at the same time? So minus 20x to the fifth plus 24x squared minus 28x. On the bottom, 2 squared is 4, x squared squared would be x to the 4th. So 40 minus 20 is 20x to the fifth. 12x squared minus 28x. Can I reduce anything here? What could I divide everything by? A 4x. So if I take a 4x out of everything, 5x to the fourth plus 3x minus 7 over x cubed. Now this is going to be written a little bit differently than if you did it the other way. You know, if you first simplified and then did the derivative, your final answer would be 5x plus 3x to the negative 2 minus 7x to the negative 3. But they are equivalent. So we're going to kind of be getting to the point where we might have multiple correct answers that are equivalent. It's just going to look different depending on which approach you took to get to your answer. Is that one okay? Let's try a couple more. Could I do this one without the quotient rule? No, because it's more than one term on the bottom. This is my only option. So the derivative. Low, so the bottom. D high, derivative of the top. Minus high. D low. Over low. Squared. So if we multiply everything out, taking the negative through that one and combining like terms. So final answer we had a negative x to the 4 minus 2 cubed. What's wrong?
What happened to our 6x squared?
So that in there. Sorry about that. Questions on that one?
Do we want to simplify it?
So what we're going to kind of go with is any obvious simplifications I expect you to do. So, you know, if you have the same parentheses on top and bottom, go ahead and cancel out. But I'm not going to make you like try to factor the top and get things to cancel that way. All right. Last one of the day. So I want the derivative of this. So it's a fraction, so we're looking at quotient rule. Quotient rule is low, so the bottom. D high. What is the derivative of the top? Minus high. D low. What's the derivative of the bottom? over low squared. Alright, 0 times anything is 0, so that all drops out, so we just get negative 2x over x squared plus 1